Okay.
It's just something I have to.
That's right. We can edit that out. Okay, forensic science. I am back with another video about bloodstain patterns and what we can learn from individual bloodstains, meaning one stain from one drop instead of the overall patterns that we were talking about before. Okay, I just made a video a few minutes ago about how you can figure out area of convergence, where you have all the lines crisscross each other, and that shows you on a horizontal plane where that came from. Okay, now we're going to add another dimension to that, and this is called angle of impact. Okay, we talked about before. Blood has uniform properties, and so it behaves uniformly when it flies through the air and when it impacts surfaces. So we can, to an extent, predict what it's going to do, and then the reverse of that, look at the aftermath of the stain and figure out what that blood was doing when it was in flight. So what we can do is use the stain that's left behind, and we can do some measurements with that, and then some really simple trigonometry, and we can figure out what angle the blood droplet was moving at when it struck this surface. Okay, so let's go ahead and do that. The first step is to measure the width and the length of the stain. You do not want to include the spine and any satellites that are at the end. Okay? Color this red first of all, as we're talking about blood. Okay, first thing we need to do is determine the width. That's this, and we just find the fattest part of the drop. When you're measuring, you don't have to draw a line across them, but I'm going to do it to show you how. Then we measure this. All right, and we'll say, I'm just going to make up a number, we'll say that's 3 centimeters. Okay? The length is a little more complicated because when you're looking at a droplet, you're not going to have this line to show you the back of the drop where it ends. It's just going to be a long tail. Okay? So what we're going to actually do is kind of trick the system. All right? We are going to use the line, and what you can do with an actual blood droplet that's still wet, so you're not trying to draw on wet blood, is make a little line off to the side here, and then one there. Okay, and then you draw a line from there to the front. I guess you could do it off here, and then measure that. And we would measure this, and I'll say that's 6 centimeters. Okay. Now that's not our length, that's just half of it, so we have to double it. So if that's 6, then this whole length is 12 centimeters. Okay, so remember, do not count this. Measure your width first, and once you've done that, measure from the widest part forward to give you half the length. Measure it, and then double it to get your actual length. Okay? Next thing we need to do is divide those numbers, and it is width over length. Common mistake is to do length over width. What you want to do width over length. So this is going to be 3 divided by 12, which gives us 0.25. Okay? You'll notice that this number, 0.25, is less than 1. When you divide these, you should never end up with anything greater than 1. Okay? It is possible you could end up with 1.0, but if you have 1.3 or 2.0, you did it backwards. You divided your length by your width. Okay? Because it's impossible for a droplet of blood to be wider than it is long. That would defeat physics, and you can't do that. Newton gets mad. Okay, so we have this number now. That's not done. What we need to do here is this is where our actual trig comes from. Okay? We're going to use what's called an arc sign, and on your calculator that'll be sine to the -1. Usually it's second or shift and then the sine button, which is how it is on this sweet TI 30XA solar calculator. Okay, so I'm going to take 0.25 second sine, and that gives me 14.4775121 repeating. We're going to round that to the nearest tenth and say 14.5. Okay, and we're talking about an angle here, so obviously this measurement needs to be in degrees. Another common mistake, make sure you are doing the arc sign, so second and then sine, instead of just the sine. Also, make sure your calculator, if you have a graphing calculator especially, and you're in calc, you use radian a lot, make sure your calculator is not in radian. Make sure it is in degrees, or it will screw everything up and then the earth will collapse on itself. So don't do that. Okay? Let me erase this. All right, so we can put those things together, the area of convergence and the angle of impact, and we get what's called the point of origin. And yes, the acronym is POO. Okay, and what this does is it shows us a three-dimensional point. So imagine using the area of convergence along the floor and then the angle of impact of a bunch of different drops, and we get this point out in space three-dimensionally, and that shows you where the injury occurred. All right, where did the blood start from when it left the person and started flying? Okay, and this is very important when trying to reconstruct a crime, to know where the victim was, where an injury happened. Okay, I have a little video clip here, and I'll have to put a link into my YouTube video so that I don't have to put it on the, or play it in a video, because a video in a video seems a little crazy. That's like Inception, right? All right, so like this and turn the light on. Let's do one more example. Okay. So I have a droplet of blood. I'm going to do the width first. I think the widest part is right about there. And that is 12 centimeters. So I'm going to draw a line. 12 centimeters. All right. So that's our width. Now, to do the length. We can't do the whole length. We're going to do half of it. And we do that by measuring from our width line and going up to the top. So that is 9. So this is 9 centimeters, which means the entire length, which would be something like here, is 18 centimeters. All right, our next step is to divide. We do 12 divided by 18. That gives us 0.66 repeating. Okay. 6, we'll just round that up to, no we won't, we'll go 0.6. Okay, and then we need to use our calculator to figure out the arc sine of that. So I already have this. Second sine, wait for it to calculate, and that gives me 41.81. So we're going to say that's 41. We'll just round to the nearest degree. That makes the most sense. And we will say that is 42 degrees. So width, and then figure out length. We measure half of it. Okay. And then we double that, so the half is 9, double it, we get 18. 12 divided by 18 gives us 0.6. It was actually 0.66666 repeating, 2/3. Okay, so I did the second sine of that, which will look like this, sine to the -1 on your calculator. That gave us 42 degrees. Okay? Remember, your calculator should be on degrees, not radian. Blah. No, don't do that. Okay? Good luck.